In this video, we're going to be looking at how to find the distance between 2 points. In other words, we're going to look at how to find the length of a line segment so that has those 2 points as its endpoints. So first of all, we're going to start off pretty simple. We're going to start by looking on a number line, and then we're going to take it a step up and look in the coordinate plane. So let's say we have a number line, and let's just number it -4, -3, -2, -1, 0, 1, 2, 3. All right, so we have our number line here, and let's say we have one point that's right here. Let's call that A, and another point over here. Let's call it B. Well, the distance between 2 points on a number line is simply the value of one point, let's call it x2, minus the value of the other point, let's call it x1. Or when I say the value of, I mean the location of. So we also need to make sure that whatever we do get when we subtract, we just make that value positive, because distance is a positive value. So, all right, let's see what that looks like when it's done. Let's call this x2 and let's call this x1. Now, would it matter if I had switched it around and called this one here x1 and this x2? Well, it shouldn't matter, because we're going to make the value positive regardless. We're going to find the absolute value. All right, so let's do it. So we have here 1 minus -3, and that's the absolute value of that. So we have the absolute value of 1 plus 3, which is just the absolute value of 4, which is still 4. All right, so finding the distance in a number line is not so hard. I also wanted to point out that if you look at the number line, from here to here is 1, from here to here 2, 3, and 4. So it's pretty easy to check that this is in fact 4. Now, finding it in a coordinate plane is not as simple, but it's pretty much not that bad either. So let's look at how that would work out. Okay, so now we're looking at 2 points, but they're not on a number line, so we can't count going straight across and we can't count going straight down. Or can we? Well, that's the question. Okay, so we have 2 points here joined by this line segment. So we're really being asked for the length of that line segment. And we can't, as I just said, we can't just count the length of that line. But actually what I said before is we can count going straight down. We can going straight across, but that doesn't give us the length of that line. We can't just add those numbers up. Or can we? Well, here's the thing. If I count the distance from here vertically, and if I also count the distance from the points horizontally, I just created a right triangle. Now, what is the length, the height and the base of my right triangle? Well, going across from point A, which is at an x coordinate of 1, going across to point B, let's call that point B, we're going from 1 to 6. So as we know, we can just subtract those coordinates, and we get that the length here of the base is 5. Similar idea, going from here vertically up to A, so going from B vertically up to A, we're going from 2 up to 4, so the height of our triangle from 2 to 4 is 2. So we just subtracted those values. All right, so now we're looking at a right triangle with a base of 5, a height of 4, and we do not know the hypotenuse of our right triangle. This means that we can actually just do the Pythagorean theorem to find out what the length of this line segment is. So our Pythagorean theorem states that a squared plus b squared is equal to c squared, where these are just legs. So the sum of the legs squared, and the c is the hypotenuse, the longest side. All right, so we can go ahead and complete this by doing 2 squared plus 5 squared is equal to AB, the length of that segment, squared. All right, so now we have 4 plus 25 is AB squared. And so AB squared is 29, and AB therefore is the square root of 29. And that would be our answer. Now, I'm sure you've heard of something called the distance formula. And you're wondering, well, why am I doing Pythagorean theorem? Because there is a distance formula. Well, here is the thing. The distance formula and Pythagorean theorem are the exact same thing. So if you think about what we did here to figure out that 5, we did x minus x2, minus x1. And to figure out that 2, we did y2 minus y1. So ultimately, we ended up doing x squared, so that squared, plus that squared. So, all right, what is the distance formula? I'll show you now. The distance formula states that d, which is distance, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. If you're a Pythagorean theorem type of person and you love to use the Pythagorean theorem for everything, well, you can't, but you can certainly use it for this. But if you want to just jump straight into the distance formula, feel free to jump straight into the distance formula. I'm going to show you this question again really quickly using the distance formula and showing you that they are in fact going to have the same result. Okay, so same points. I'm just not showing you the graph this time, but same points. And this time we're going to use a distance formula. So the distance formula states that distance is x2 minus x1 squared plus y2 minus y1 squared. All right, so we have to name our points if we're going to use a distance formula. I named this x1 and y1. x2 and y2. It actually doesn't matter which one is x2, y2, and x1, y1, as long as you're consistent. So of course, 1 has to go with 1, and 2 has to go with 2. With that said, now we're ready to plug straight in. We get that d is equal to the square root of 6 minus 1 squared plus 2 minus 4 2 minus 4 squared, which gives us the square root of 5 squared plus negative 2 squared, which ultimately gives us the square root of 29. And as you can see, using Pythagorean theorem is the same exact thing as using the distance formula. So choose whichever you prefer.